Hey there. All right, so for this video, we're going to be walking through how to conduct a logistical regression. Specifically, we're going to be walking through how to conduct a simple, multiple, and hierarchical logistic regression. And a little bit about logistic regression. The purpose of logistic regression is to understand the predictive power of a set of predictors given the fact that we have a categorical outcome variable. That is, we have a variable that is either a 1 or 0. It's a dichotomous variable. It's either on or off. To further illustrate that, let's go ahead and pull in our data set. To do that, I went to Import Dataset, went from Excel, click Browse. My data set was saved to my desktop. So once I found my data set, I click Open, and then I'm going to import that data set. Alright, so this is the data set that we're going to be working with. In this case, we have a set of predictors, locus of control, coping style, teaching, research, and a pastoral variable. It's like a religious variable. But these are our predictor variables. And in this data set, we're trying to predict the outcome variable, burnout. And with burnout is essentially, it essentially refers to mental and or physical collapse due to overwork or stress. So in this case, we're looking at people that are the likelihood or the predictive power of these variables, these predictor variables, in predicting the outcome variable burnout. That is, people that burned out versus people that did not. So it's a 1 or a 0. 1 equals burnout, 0 being not burned out. But that's a kind of example of some of our categorical variables that we still want to be able to predict the chances of being in one group versus the other group. So people that burned out versus people that didn't, for example. So that's pretty much the main purpose of regression, is to again have an understanding of how predictors contribute to an outcome variable that is categorical. Alright, so let's go ahead and get into the next bit of our syntax here. So here we have, of course, we have our library package that opens and reads our Excel file. In this case, I specified the data set that I wanted to use. I got this bit of code here or bit of syntax rather, from the import command, where I hit Excel, I browse for my data set again, and once I pull in that data set, I click Open. Here's the same information we find here. That's the path for my data set. But I put that information here so that when I run this data set, I don't have to constantly recall the data set and re-import it every time. So this is what our read Excel function allows us to do, is specify the specific data set that we want to use. And then once I've specified the data set I want to use, I want to go ahead and attach that data set, which equips it and calls it into into R's environment to reference. So it's kind of like saying we're going to use this data right here, this data set right here for the next bit of code. And so there we see in our next bit of code we have Excel.data, which again we pushed. We see here we have our data set reference, and we push that information into the variable Excel.data. That's kind of like Excel data set, if you will. All right, so I'm going to go ahead and run. I'll tell you what, I'm going to go ahead and run this whole bit of syntax, and we're going to talk through it. All right. Boopity boop boop boop. All right, so to start here, we've got our data set. Kind of know what we're running, what we're looking for. Again, we're looking for burnout or not burnout, the lack thereof. But one of the parameters of the assignment was that the continuous predictor variables could not be correlated above 0.4. So to test that, I ran a correlation in R, essentially using a core command. I loaded my data and I specified the variables, the list of variables that I wanted to reference in this correlation matrix. So if we go here. Boop, boop, boop. This is our correlation matrix in R, and we see that if I look across our variables here, coping correlated with locus of control, a 0.2, negative 0.2, 0.2, 0.1. Yep, looks like we're good on that. So none of our predictors are significantly correlated above 0.4, so we're good to go on that. So now we get into our actual set of logistical regressions that we're going to be running. Again, we're going to be running a simple regression, a multiple regression, and a hierarchical regression. With our first model, our first logistical regression, we use this bit of code here, and we see we use the glm command, which basically says this is a general linear model, and we specified the outcome variable burnout, and then we had a tilde sign, which basically is saying burnout. We want to regress the variable burnout onto the predictor variable research. And then we have a family variable, or a family condition in which we are specifying the family. So in other words, we're telling R what type of regression we're going to be running. In this case, we're saying that it's a binomial regression, which is another way of saying it's a logistical regression with an outcome variable that is binomial. And then we have our model summary. So there we see we've run this model in which we have seen how research predicts the outcome variable burnout. But let me back up and walk through a bit of this data set. Again, we have the variable burnout. That's our outcome variable. So looking at people that did not burn out versus people that did. Then we have a locus of control variable, which is looking at, so because this is dealing with like teaching and research, we're going to assume that this is a sample of professors. So this locus of control variable would refer to the degree to which these professors perceived that they had control of their environment, of their situation. And then this variable here, this cope variable, is referring to the type of coping style that they had, or the degree to which they had their reported coping style. Similarly, we have kind of looking at some of our stress variables, which would be like the degree to which they teach, higher scores being more teaching involved, higher research scores being more research projects, more research workload, if you will. And this pastoral variable is kind of like a similar coping variable. It's a religious variable, looking at the degree to which they espouse religious views or whatnot. So that's a little bit more about our data set. So when we run this model, we're going to look at what the implications are of each predictor. And when we look at the model summary, we see that research in this first model, research by itself, is significant. And we would report this using this information here. And to get this information, basically what we did is specified or called out the information from our summary here. So for example, we included, this would be our chi-squared degrees of freedom variable, our chi-squared variance variable, and our significance value for our chi-squared. And to get those variables, we referred to model 1 and specified that we wanted to call the degrees of freedom null, and we wanted to subtract the null from, that we wanted to subtract the model 1 df residual from the null. And then we wanted to push that information into the degrees of freedom value. So basically what we're saying is, what is the difference between the null and the residual in terms of degrees of freedom? And we see that value in our code, which is 1. So in other words, we're saying we have null degrees of freedom. So it'd be 466 minus 465, and we get the value of 1. And then this rows command here, in row, in our data set, basically is counting all the rows in our data set. And we see if we scroll down all the way, it'll catch up for me. There we go. We see that we have an n number of observations of 467 entries. So in other words, it's just counting up the number of rows that we have in our data set. In all my rows, this is simulated data, so all my rows actually have relevant responses. And so there's no missing data, no missing information. All right, so next we have our chi-squared variance. And to get that, we're similarly as to our degrees of freedom, we're going to specify the model that we want to select from. In this case, it's still model 1. That's the only model that we've run. And again, we're doing null deviance minus deviance. So it would be 530.11 minus 523.76. And that would give us our chi-squared variance. Then we want to see if this information, our variance and our degrees of freedom, if when we subtract that information by 1, or no, if we subtract that information from 1, do we get a significant p-value? So in other words, is our model significant? And we would want a value of less than or equal to 0. And here we see that we have a value that is 0.01. So it's fairly close to 0. So I would argue that our variable is significant. Research, it's not very significant, but it is pretty close to 0 as opposed to 1. So that would suggest that research is a significant predictor of burnout. That is, having a workload that is research intensive, logically we would know that that would lead to increased workload, increased stress, and things of that nature for a professor. So that would kind of make sense logically. All right, so now we're going to look at the odds ratio for this model, our model 1. And the odds ratio basically gives us some information about the likelihood of the outcome occurring given the predictor, or given an increase or a decrease in the predictor. So if the odds ratio is greater than 1, that would mean that an increase in the predictor would also have a corresponding, so if I can rephrase this. Basically, as the predictor increases, the odds of the outcome go up as well. If the odds ratio is less than 1, as the predictor goes down, the odds of the outcome also go down. So let me see if I can make that make sense a little bit using our odds ratio number. Okay, so we have an odds ratio for research that is 0.98. Now that variable, or that number, is pretty close to 1, but it is still less than 1. So we would say that as research goes down, the predictor, as the unit of research goes down, the odds of the outcome go up. Now that's not exactly, because it's so close to 1, I would still argue that conceptually it makes sense that as research goes up, the likelihood of burning out goes up. I'm not exactly sure why that value is less than 1. All right, so then we look at our confidence interval around our odds ratio. Oops, this should be CI, not. Oops, this should be CI, not IC. So it's confidence interval, but we'll move on. So again, this is our odds ratio. It's our confidence interval around the odds of the outcome occurring. So we're going to look at research, and we want the upper limit and the lower limit, or excuse me, the lower limit and the upper limit to not include 0. And we see that with this confidence interval, we do not have a 0 included. So we would conclude that research, the variable research, significantly predicts variance in the outcome burnout. All right, let's move to our, and so that would be our simple logistical regression. And by simple, I mean that there's only one predictor included in the model, and that predictor happens to be research. But next, we have a multiple general linear model that's running a multiple logistic regression. And basically what that means is that when we've got a bit of code here, we've included extra predictors in addition to research. So instead of just running the model with one variable, one predictor, we ran the model with 3 of our variables. And again, we're running a general linear model, and we're regressing the outcome variable burnout onto the predictive variable research, locus of control, and coping. And again, we're specifying that this is a binomial model that we're running, so it's a logistical regression. And again, we're running our model summary, and we're conducting a bit of the arithmetic for the significance test of model 2. So this would be our second model in our sequence. And again, complete with our odds ratio and our confidence intervals around the odds ratio, as well as our the calling for the individual significance of our output, so that we can basically, what this does when I type these things again, it invokes these variables. So in other words, all of this information, all of this arithmetic is just pushed into these variables. In order to equip them or call them forward, I have to type them out in our code here and hit enter. Once I do that, my variables display. All right, so you'll see those here. But before we do that, let's kind of walk through our model summary. And here we see in this model, model 2, we have the variable research, locus of control, and coping. And we see that looking at our intercept, or looking under our intercept here, we have our predictors, as well as their point estimate, their b-values, and our walled statistics. Oh, that's another point I forgot to mention. I'm going to go back up here. This z value here, this p-value for the associated z value here, is our walled statistic. And a walled statistic essentially indicates whether the point value that we have, this point value here, this b, is significantly different from 0. And so this would argue that, yes, in fact, our point estimate, our b value, is significantly different from 0. But it's in the negative direction. So that means as research goes down, burnout goes up. Or no, excuse me. As research goes up, wait a minute. Right, yeah, okay. So as research goes down, the likelihood of not burning out goes up. That's kind of what we'd expect there. And again, we have our bits of code here. So we have our model with our additional predictors. And then we have our arithmetic for our chi-square degrees of freedom, our n, which shouldn't change ideally, and then we have our chi-squared variance, and then our chi-squared significance value, our p-value. So let's go ahead and look at that, some of that information there. Again, we see our chi-squared degrees of freedom is 1. We still have our sample size of 467 participants, and we have our chi-squared variance is 6.35, and we see that this model is significant because it is less than 0.05, so it's 0.01. So then we're going to look at our odds ratio, and again, the odds ratio is referring to the likelihood of the outcome occurring given a unit increase or decrease in our predictor variable, or variables in this case, because we're running a multiple logistic regression. After I go back down here for model 2. Okay, so now we're looking at, oops, I went up too far, but there we go. So excuse me, I misspoke. This bit of code is referring to our model 1, and this bit of code is now referring to our model 2. Our degrees of freedom is 3. Our number of participants is 467, and then our chi-squared variance is 168.56, and then our p-value is still significant. It's less than 0.01 or 0.05, depending on your level of significance there. Now we're going to look at our individual odds ratios for research, locus of control, and coping when we consider all three of them together. So our odds ratio for research is 1.02, and our odds ratio for locus of control is 1.067. Then we have a coping odds ratio of 1.09. Now basically what this is saying again is that because our values are greater than 1, all three are greater than 1, we would say that because our predictor goes up, the odds of the outcome go up. So as the odds of increase go up, or I mean the odds of the research go up, as the unit of research goes up, the odds of the outcome burnout go up, which is what we would expect. And as the odds of locus of control, higher scores mean lower locus of control. In other words, lower perceived control for some of these professors. And so lower perceived control, as we would expect, would mean the greater likelihood of burnout, greater instance of burnout. Now, coping strategy is interesting because coping strategy refers to their coping style. And high scores, I believe, let me check. Boop-de-boop. So high scores indicate greater ease of coping, which is different than what we'd expect. Because we'd expect ease of coping to be something that allows you to kind of alleviate burnout. So it might be the case that as coping goes up, the likelihood of not burning out goes up. But so those are our odds ratios. That's how you would read that. Then we're again looking at our confidence intervals around our odds ratios. We do not want these intervals to include 0, and we see that none of them do, so we're good on that. All right, so now we're going to walk through our third and final model, but good news is we saved the best for last. And this is our hierarchical linear logistical regression model. And with this model, what we basically do is enter one variable at a time or well, not one variable at a time, but we enter one variable and then we add a predictor in the next variable. So it's like it's kind of a stepwise approach in the sense that we have stages that we add variables in, but it's not conceptually or computationally the same as a stepwise regression. If I can kind of unpack that a bit, what I'm saying is basically in the first model we're going to enter a single variable. In this case, we're going to enter coping. In the second stage, we're going to enter coping plus our locus of control variable. And then our third and final stage, we're going to enter all three variables at the same time in this model. And what we're trying to see is when we control for coping, is there an incremental prediction that adds to the variance explained by coping when we add the variable locus of control and when we add the variable research. And so that's a bit of conceptually what we're trying to see. So anyway, what that means is when we add a predictor, does the new predictor incrementally predict the outcome over and above the first predictor that we entered in the first stage? So does locus of control and research incrementally predict burnout over and above coping? Yes or no? And so we're going to look through the significance of our model and see what we find. All right. So again, our first model is still have a general little model with our outcome burnout. We're going to regress that onto variable coping. And as before, we have our arithmetic to get our chi-squared degrees of freedom, our chi-squared variance, and our significance value for our chi-squared test, as well as our odds ratio and our odds ratio confidence intervals. But let's go ahead and look at that. Again, we have degrees of freedom of 1, sample size of 4.67. That hasn't changed, so that's good. Then we're looking at our chi-squared value. Our chi-squared value is 131.07, and that value is significant. So this is like it's the analog of our F value or F test in linear regression. So in other words, we're looking at the likelihood of an outcome occurring, essentially. And that is that our model is significant. The variable coping is greater than 1. So as coping goes up, the outcome of burnout goes up. I think I might have miscoded that maybe, because ideally we would expect that as coping goes up, burnout goes down. So this is not what we'd expect. We'd expect this value to be less than 1. And we do have, with our intervals here, we do not include 0, so the confidence intervals for our odds ratio are significant. And then we have our next model. And I forgot to mention, the first model here is comparing our coping predictor against the null model, which is when nothing is included in the model. It's essentially like the constant. So looking at this model, whether or not it's significantly different from 0. And then that's what happens when we compare it to the null. Similarly, when we include the other two variables in our second step, we're looking at whether or not these two variables are significantly different from 0, different from the null model. And we see that they are. Looking at our Wald statistic. Our Wald statistic should be less than 0.05, and we see that all three of them are, or excuse me, all two of them are. And again, so that means our point estimate is greater than is significantly different from 0. But so what we're doing with this first bit of code for our third model here is we're comparing the variables to the null model. Is this model significantly different from the null model in each of these iterations here, each of these steps? Then we're going to compare the models. Once we know that these models are significantly different from 0 in and of themselves, we're then going to compare these models to each other to see that's getting at our incremental prediction part of a hierarchical logistical regression. That is, we're saying is when we included coping in our first model, does adding locus of control significantly predict the outcome burnout over and above coping alone? So here we look at our significance information for our first model, our first comparison rather, and we see that P is significant, so that would tell us that locus of control significantly predicts or incrementally predicts over and above the variable coping. And then we would go to the next set where we compare. So this first set was comparing model 1, that the variable coping, to model 2 that included coping and locus of control. Now we're going to compare model 2, which is coping, locus of control, and model 3 that includes all 3 variables, coping, locus of control, and research. And we're going to see if that variable or that set is significant. Oh, I'm sorry, I misspoke. Again, to reiterate that, this set of code here is comparing the first model from 0, from the null. And then, so you don't really have to run this comparison because you already ran it up here essentially, but I changed the variable. The first variable was research that I input in our very first model. But that for this this third model, this hierarchical model, I changed the first variable that I inputted because I wanted to control for coping style across professors. So I entered that as a control variable in the first bit. So this would be comparing the first model of the series of model 3, where I included coping as the first step. So this here would be the bit I'm referring to, where I only included coping in this model. And next, we would look at coping plus locus of control. So model 1 compared to, this would be that. So our first bit with step 1 is saying that coping significantly predicted burnout. Then we're looking at whether or not locus of control incrementally predicted burnout over and above coping, and we see that we have a value of less than 0.05. So yes, we would say that locus of control incrementally predicted burnout over and above coping by itself. Now we have our last variable to compare. So now we're going to compare the model 2 with our last model in the model 3 series, which is saying model 2 that includes coping and locus of control. We're going to compare that to the model that includes all 3 predictors, which are coping, locus of control, and research. And we'd expect that variable or value to be less than 0, or less than 0.5. And we see that it is. But let's go ahead and look back up at our a third model, I think, we see that coping is significant and locus of control is significant, but research is not. Interesting. Or certainly not as predictive or as significant as coping and locus of control. But that is how you would run a basic or simple logistical regression, a multiple logistical regression, and a hierarchical logistic regression. Cheers.